So I just hit the over under button and then type it in. 5 minus negative 2, negative 1, minus negative 8. It's just going to give you a slope of 1. Not that big of a deal. Then to find the equation of the line, you got a gate tonight. I don't know what you are, gay, straight, or bi, but you got to go out with either negative 8, negative 2, or negative 1, 5. Who you going to pick, kid? Ain't no negative 5. You got to pick one that's on the table. This one here. So I'm going to write that down. It's negative 1, 5, and my slope equals 1. So this formula is going to show up a lot. Y minus y sub 1 equals m times x minus x sub 1. Y minus something equals something times x minus something else. And then that 5 just falls down in. That slope comes over, and the negative 1 comes over, but it's negative negative 1, so it's going to be positive 1. And I think they'll let you stop there. In calculus, they usually let you stop there. If it's a type-in question that says y equals, then all you have to do is add the 5 to both sides. So it would be 1 parentheses x plus 1 plus 5. Alright? Domain of x values, so the domain starts here on the x values. So it's going to be the lowest x value to the highest x value. So notice the lowest x value is negative 3, and the highest x value is 1. But notice the negative 3 has an open circle in it. See it? So the domain is going to be parentheses, comma, 1, bracket. Closed circle gets a bracket. Open circle gets a parenthesis. Yeah. Range. The lowest y value is here and here. So the lowest y value is negative 4. The highest y value is here and here. Now some people say it's an open circle there, isn't it? But it's a closed circle there. So we take that y value as 0. And it's going to be from the lowest y value to the highest y value. So the range is going to be from negative 4 all the way over to 0. Alright, domain of a logarithm. You're not allowed to take the log of 0. You're not allowed to take log of a negative number. So all you do is come over here, and whatever's inside of the parentheses, it has to be greater than 0. So you're going to rewrite it as 6 plus 3x is greater than 0. And then start solving it. Minus 6 from both sides. So that's going to give me 3x is greater than negative 6. Divide both sides by 3. So that's going to give me x is greater than negative 2. Now if I were to graph that on a number line, I'd find a negative 2 on the number line. Open circle. I don't fill it in because it's only greater than. And then notice, if you solve it and the x is on the left, you just follow the arrow. The arrow points to the right. And then the interval notation would be a parenthesis on the negative 2. And how far to the right does it go? Forever. Infinity. And you always put a parenthesis on that. Alright, limits. That there's a left-handed limit. It approaches the x value of 1. Approaches the x value of 1. It approaches it from the left. What y value do I get closer and closer to? 2. It's the same question. Alright, there's probably a typo. So let's do that from the right. Let's make it a right-handed limit. Okay? So now I'm approaching 1 from the right. I'm getting closer and closer to the 1 value. The x value of 1 from the right. What y value do I get closer and closer to? That's a 3. Now, this is from both sides. Because there's a jump there. See how there's a jump? That's a DNE. Lindsay Lohan. The limit does not exist. Alright? Now, the limit does exist at this hole. Because it doesn't do that. If it's got a hole, the limit exists at the hole. But if it's like this, if it snaps away, you have to jump, no, the limit does not exist. And notice, they say at 5, as the limit approaches 5, from both sides. Notice, as I get closer and closer to it from the left, the y value gets close to 4. As I get closer and closer to it from the right, the y value gets close. So the limit does exist, and it's 4. This is algebra. This is not calculus. When x equals 1, what does y equal? It's got to go with the closed dot. And the closed dot is 2. Because that's where there's a value. There's no value at 3, at y value 3. Has to be where there's a closed dot. Now this one, in algebra, if x equals 5, what does y equal? No, there's nothing there. It has to be closed in order for you to answer this question. So that one's DNE. Or they might do this. Do you know what I mean? No solution. Is f of a defined? So, when x equals 4, is there a y value for it? Yes. Now, if there was nothing there, then that would be not defined. See how there's no y value at x equals 4? Because I erased it? That would not be defined. But because there is a y value there, it's defined. So that one checks out. This one is good. The limit, as x approaches 4, exists. Yeah, as I get closer and closer to 4 from the left and the right, it does exist. So that one's good. So it has to be the third one. What does that mean? That means the limit as x approaches 4 from both sides is actually 5. But, what's that coordinate there? Isn't that coordinate 4 comma 4? Does that y value 4 equal that y value 5? No. So that's where it doesn't work. That's where it's violated. These are nice calculator problems. The base is 32, so you're going to hit this log button with the little base down there. And the box up here. And that button's right underneath the on button. So if you hit that log base button, and the 32 goes down here because that's the base. The 32 goes down there, and the 64 goes there. Type that in, hit equals. That's not quite your answer yet. That's not quite your answer. So log base of 32, log base 32 of 64 equals 6 fifths. Okay? Now what you have to do is go back to middle school and type this or write this down. X minus 8 equals 6 fifths. And while that's still in your screen, you're going to add 8 to both sides. So your answer is going to be x equals whatever 6 fifths plus 8 is. I got 46 fifths. Oh, you hit SD? 9.2. So the fraction is 46 fifths or 9.2. It shouldn't matter on the computer. All right, this one we got to be careful. We're going to hit the log base button again. But this time the base is that big number, 1,000. And the other box up there is going to be the 100. It should fill in pretty nicely. You're going to probably get a fraction for an answer. So the log base of 1,000, log base 1,000 of 100. And you get 2/3. 2/3. The derivative of e to the x is e to the x. So that's going to be 3 e to the x. It doesn't change. The derivative of 3x is just 3. And the derivative of negative 3x to the 4th, I do the power rule. I do 4 times 3. So that's going to be negative 12x, and then I minus 1 from that to the third. For the final, what you have to realize is sometimes you're going to be doing the derivative, and sometimes you're going to be doing the antiderivative. I use a little graphical organizer for the product rule. Most of the time I just FOIL it out, but I have an e to the x in there, so foiling it won't help me. I crack it down the middle like an egg, okay? And then I set up a little t-chart. And I take the derivative over here. So that derivative is going to be 24x to the 5th plus 63x to the 8th. Then I take this derivative. That's going to be 6e to the x. And then I crisscross applesauce. I'm going to do this derivative times this derivative. And you just got to set up some butt cheeks. You just got to just quantify everything. 24x to the 5th plus 63x to the 8th times, and that one's already in butt cheeks, 6e to the x minus 5, close parentheses. And then see the plus sign? See the plus sign there? That's the quantifier. So I'm just going to add these two derivatives. This plus this. Or that times that, I'm sorry. I multiply them. So that's going to be parentheses 4x to the 6th plus 7x to the 9th. Parentheses 6e to the x. Sometimes you don't even have to put that in parentheses. You can just leave it hanging out there at the end. All right, get the calculator ready. We got to do chain rule. So get the calculator. I don't know what 8 times 13 is. So bring that over. Help me out. What's 8 times 13? That's going to give me 104 in front. And then minus 1 from the exponent, so that's going to be 2 to 12. And I just copy that down. Just copy that down inside here. So that's going to be 2x cubed plus 3x to the 9th inside. Chain rule, all I have is one more step. One more step. I'm going to set up my parentheses in the back end, and you just come in and take the derivative of the guts. So the derivative of 2x cubed is 6x squared plus 27x to the 8th. Done. Done. You're not expected to FOIL this out or distribute or anything. No. The whole thing is the answer. The whole thing is the answer. All right, before we do the calculus of this, we got to realize that x cubed looks like this. It's a positive x cubed, so it's going to look like that. And the local min is going to be the second x value, and the local max is going to be the first x value. And how you find them is by taking the derivative of this. So we're going to take the derivative of this monstrosity. That's going to give me 3 times 4, which is 12. 12 divided by 3 is going to give me 4x squared minus 48x plus 128. And then I set that equal to 0. Now, I don't know if you know this, but an x squared is a parabola. And where that parabola has an answer, where that parabola equals 0, right there, that's going to be my min. I'm sorry, that's going to be my max. And right there, that's going to be my min. So all I do with this is mode 5 3. Mode 5 3 that. All right, what's 3 times 4? Divided by 3. That's 4, and then I minus 1 from the exponent. Then I do 2 times 24, 48. Okay? After you mode 5 3 it, tell me what your two x values are. It should say x sub 1 and x sub 2. Mode 5 3, I type in a 4 equals, a negative 48 equals, and a positive 128 equals. I get x equals 8 and x equals 4. So my x sub 1, 8 and 4. 8 and 4. Good? Good. So notice 4 comes before 8. So 4 there, 8 there. So my maximum value is going to be 4 comma something. My minimum value is going to be 8 comma something. Local min is at 8. Local max is at 4. Now, I would mode 7 this. Mode 7. And type that monstrosity in just like it looks. It's going to ask me. Yeah. You got to plug that 4 in and that 8 in to the original. So we're going to type that in mode 7. And then it's going to ask me where to start after I type it in. And I'm going to start at 4. And I'm going to stop or end at 8. And then my step. How far is 4 from 8? I would step by 4. Mode 7 is my table function. And then I'm going to type in 4/3 alphabet x cubed minus 24 alphabet x squared plus 128 alphabet x plus 1. I don't need g of x, so you just hit equals. I would start at 4, and I would end at 8. And I would step by 4. The 4 value is going to be 643 over 3. And my 8 value would be 515 over 3. Did you get those? Yeah. And that's an over. Did I enter it correctly? Alright. You know, it gives you a decimal of 214.33 and 171.66. But you might want to hit SD and see that that 214.33 goes out really far. And it's 171.666666. Remember, if it's a computer, you want to fill up the screen with those decimals. I would do the fraction. I would actually do the fraction. Huh? Yeah. So at 4, it's 643 over 3. Now be careful, because the 4 is the bottom one here. Remember, this is 643 over 3 with the 4. And then this one at 8. No, I messed up. Shit. The 4, yeah, I did. Damn it. 643 over 3. And the 8 value is 515 over 3. Alright, I gotta go.